If you're looking for more content about Kubecon North America, then this episode is for you. Welcome to the Is It Observable YouTube channel. Today's episode, you may expect an episode related to technology, but you are completely wrong. Because I did so many interviews in Chicago on different projects, I can technically offer you a third episode with more interviews and sharing the experience of Kubecon North America. In this episode, I will mainly highlight the updates related to Fluentbit 2.1 with the interview with Eduardo Silva. And also I included the interview about Litmus Chaos. They recently upgraded their UI, lots of improvements, so it deserved to be shared with you guys. All right, so if you enjoyed today's content, don't forget to like and subscribe to the channel. So follow me in Chicago. At Kubecon, that's it. Conference will end. A lot of people, a lot of great news. It was a great conference, to be honest. I like the venue. I like the city. Still have some more interviews to do today. Especially Fluentbit. I want to see get the latest news about Fluentbit. There's a couple of auxiliary solutions I want to also interview. Yeah, we'll see. Quite a shorter day than the other days of the conference, but very excited to have this last day of the conference. All right, let's go.
Hi, I'm Kautilya Tripathi, and I'm a software engineer at Microsoft, and I work with the Azure Core and the Linux team. I'll be presenting Headlamp. It's a CNCF sandbox project that we develop at the Microsoft.
And what is the Headlamp about?
So Headlamp is a extension of the Kubernetes UI. It's a revamped Kubernetes dashboard, you could say. It's totally like you can configurable it, you can edit it however you want, and yeah, it's a Kubernetes dashboards to be precise. It's secure and it's totally configurable.
And so basically every single command that we can do with kubectl,
Yep.
you basically can get the similar results in Headlamp.
Yep. Whatever you create with your Kubernetes resource, whether you can easily view it on the dashboard, and yeah, you can even edit those resources in the dashboard. You can even create those resources on the from Headlamp. Headlamp can be run in a different form. It can either can be run as a web application, either a client application. Currently, the application, this is a Mac. I've installed the application on the MacBook, and it's available on Linux as well and Windows as well. It has two components. One is the client, another is server. You can even install this Headlamp in cluster. That is, you can install it via Helm charts. So yeah. So this is the multi-cluster. Like if you can have multiple clusters or a single cluster configured. Currently, we have 3 clusters configured. 2 are currently not working since it's Minikube. I have closed my Minikube. It takes from your kube config and loads these clusters. So this is your the cluster that we have running on Azure, and this is the initial web page. You get metrics, you get CPU, memory usage, and the pods. You get all the events that you have currently running in, and every Kubernetes resource can be viewed from here, whether it be the namespace that you have running in your cluster, your workloads, pods, replica, daemon sets, jobs that you create, your storage information, your security, like your service accounts. You can even create roles from here. So let me show you a simple pod. So this is all pods that are running. You can either filter them with namespaces. You can even filter with a direct search.
Like with a label selector?
Yeah, you can even filter with a label selector. And you have this, you can even change the columns from it, like which columns you want if you don't want to see the names. And it's written in React, so it's everything that you change here, it's directly changed on the application. So let me open a simple pod. You can, the best part is that you can even view metrics from it. When you open a pod, you have CPU, memory, and you can easily view the Prometheus metrics from it. And the whole information about the pods, how is it running, its tolerations, its container informations, and which volumes and events are all shown on this pod info.
And similar to other Kubernetes visualizations,
yep.
Can I see even the YAML?
You can. You have this. You have this logs. Okay, YAML. Okay, let me check. Okay. You can. I think you can. Yes, you can view. Yeah, you can even edit this pod that you are running, and you have the documentation for it as well. Like if you want to create a pod, you directly get the documentation, like
API objects. In
API objects.
Oh, that's cool.
So yeah, you can even edit this Kubernetes resource from here.
And on the networking side, I saw that your networking layer, is it mainly Kubernetes endpoints and services?
Yeah, exactly.
And ingress or gateway API if you have added it?
Yeah, everything.
And if you add let's say a mesh, would you have like a specific entry point for the meshes?
Yep, we don't have specific entry point for the meshes, but it will be shown here. But the thing is, what makes Headlamp different from other UI dashboard is that it's completely configurable. So you can create your own plugins. So it makes it different. And for example, a plugin that we have currently installed is this app catalog. So what it does is you can install any application from Helm charts from this app catalog directly.
Oh.
So you can just click on install. You can directly install the dashboard as well. You just need to type the release name, namespace, version, which version you want to install, and the description. And it will be directly installed to your Headlamp cluster.
So that's an example of a plugin.
Yeah, that's an example of a plugin.
But at the end, I can have a dedicated plugin to visualize my service mesh,
exactly,
or my
anything.
service graph, or whatever.
Yep.
And how do you build a plugin? You have a specific SDK? I guess?
We have an SDK. You can create your own plugins in Golang, so yeah, you can do that.
And how can, if I'm interested to use Headlamp, where can I have information about Headlamp?
Okay. We have a dedicated GitHub page, Headlamp, github.com/Headlamp K8. It's an organization. This year we started Fluentbit version 2 series, and we have done a lot of improvements around performance and also around the next stage of what is a data pipeline around data transformation and modification. Historically, Fluentbit has been used to collect, deliver data, but also to be able to process data at a higher scale. But with today's needs, and today's needs I mean more data volumes, we need to optimize even more the telemetry agent to support today's workloads.
So do you mean that the version 2.2 is mainly optimizations and being able to multi-thread more processing tasks?
Yeah, I will split in kind of 3 buckets. One of them is integrations, different connectors for inputs, outputs, mostly around matrix collectors now. The second bucket is around performance.
right? And the third is about a new logic that allows you to define processing rules or processors in a more efficient way that behind the scenes helps with multi-threading. So one of the first new, well, more than news, this is very well known, but we always try to tell people that and teach people that the Fluent ecosystem is a real vendor agnostic ecosystem that allows you to play and solve problems with telemetry data. And with this, I'm talking about logs, metrics, and traces, and also have a more unified experience if you're using Prometheus or OpenTelemetry, no matter what type of data you have. So Fluentbit is like, imagine that it's at the center as an observability agent that allows you to solve all the type of challenges. And as of Kubecon this week, we achieved 11 billion downloads in total, which is insane. And as I said in the welcome video, I'm very thankful for the whole community who has been deploying this agent and trusting in this technology that now is not just built by one person, right? They have maintained it from Google, from Amazon, from Microsoft, and many other companies. When you think about Fluentbit, you have to think about a pipeline, right? And a pipeline has a source and a destination, and many things happens in the middle. So what we have here on the screen is a way to describe how data processing happens, right? In the way that we are educating. So as much as you know how things work internally, the better decisions you can take for your own specific use case. So first data gets collected in number one, and after that, optionally, you can attach processors. And this could be filters, right? Filters or process that allows you to transfer and modify the data. This data internally is called just events, and events are kind of agnostic. It could be a log, a metric, a trace, an eBPF message. It could be anything, right? Once you collect this information and gets buffered, it gets on the scheduler engine, which allows you to route this information at a certain time to a specific destination, like Amazon S3, Splunk, OpenSearch, or Loki, or any type of database that you have. But the interesting piece right now that we have in the pipeline is that with the release of 2.2, now you can do processing also in the output. You can do it in the input and the output. And why? What is this? When you process data, as soon as it gets to your pipeline, you can maybe discard data that is not relevant for you. That's the first step. But then we have many users and big corporations that said, hey, now I'm going to send the data to two places. One is Amazon S3. We will have the whole payload. But also I want to take advantage of Splunk, but I don't want to send everything because it will be more expensive. I just want to send a fraction of the data to Splunk, meaning like you have 10 keys, you're going to send just 2. And people has a more efficient way to reduce costs and take the most of both platforms, which one of them is more for real-time queries and the other for archive, right? Now, going back to that too, we just released a new sysinfo plugin, which is a processor or a filter that allows you to auto-enrich metadata that commonly you will do it manually before, like what is the host name, the Linux kernel version, because there are many use cases where you need this information together inside the event. From a data collection and metrics standpoint for Docker, now in the Docker, our Docker metrics collector used to support cgroups version 1, and now we extended this to support v2. That means if you're running Docker environment, you want to collect the metrics for your containers, and your system is running cgroups v2, now you can use Fluentbit for this. It will work behind the scenes, right? It's automatic. And enhanced YAML support. Historically, we have our own configuration format called Classic, right? Which people love it or hate it, but it solves the problem. But for nowadays workloads where we have cloud native tools that everything is built on top of YAML and people has a lot of tools to manage this YAML, we wanted to extend the experience for our users and also extend it by supporting YAML configuration format. So you can use both. You can use Classic, you can use YAML, but from a training and education perspective, we're going to start using more YAML moving forward.
So it means that when you have the inputs, you can put a tag, and you can list all the inputs like you hear in examples, like an array, and then I can do the outputs. Same thing, matching the tags that I have defined. But you mentioned you said that there is processors, the multi-thread processor for each individual input. So how does it would that be represented into YAML?
Maybe we can use example that we have here. For sysinfo, as you can see in the screen, we have the input plugin, which is dummy, that generates a dummy message. And then we have a section called processors. This is a new thing. You can reuse your filters here. That's the huge plus, right? And you have processor for logs, for metrics, and for traces. In the example, we're just attaching a processor for logs that is called sysinfo with its own properties. So this filter, so this processor will just work for this specific input or source plugin that has been defined.
So for example, in the past you had the input to tail input plugin where you were processing or you were parsing, and now parsing has been removed as the processor, I guess.
Yeah, for example, tail still supports parsing inside the same plugin, but you can attach multiple parsers if you want as processors.
Ah,
So you don't need to mess with tag and matches anymore.
okay, that's great.
Now, and if your input plugin is running in a separate thread, and you do your own processing, all the processing will happen in a separate thread. So you can take advantage of your CPU cores in your environment. Okay, so our famous not exported metrics plugin that collects operating system metrics for Linux, now we just ship a new processors metrics collector. So besides collecting the metrics from the system, we can collect the metrics for each process that is running in the Linux box. And now we went beyond that and implemented the same type of metrics collector for macOS. There are a lot of use cases where companies, they want to ship, they are shipping Fluentbit agent as an agent, as a black box agent for their employees, and they want to collect metrics from the system. So how is the CPU going, memory, this usage, and also Windows, right? We have invested a lot of this year on the Windows operating system. I don't use Windows, but I know that many companies love it, so we're just implementing a lot of collectors for Windows. So yeah, some members of our maintainers have implemented these kind of collectors, and we are expecting from here to the next year, we're going to extend more the capabilities for collection across operating systems, versions, right, and different, I don't know, there are people who like to take specific metrics from specific network cards or more low-level information.
And if, for example, I guess you still have the input Prometheus where I can scrap information from the Prometheus exporters. Am I able to reduce the footprint of a metric to say I want to drop a specific label of the metrics, I want to remove a specific metric name that is exposed in that exporter? Can you do such a?
Yeah, this is in the processor's capability. So you can attach a processing rule.
And then do the removing,
you can do the draw
filtering.
or add a new label or change it. Yeah.
Okay.
You can do all this manipulation.
So at the end you have extended what you can achieve into modifying and filtering the metric data.
Yes.
And what about the traces?
Traces, now we can do the same functionality with attributes. So we get the traces and we can play with the attributes. Add, remove, update. We are formally deprecating the official Grafana Golang plugin for Fluentbit. So this plugin allows you to, it's a Golang plugin that allows Fluentbit to ship the data to a Loki backend.
Yeah.
But we have been designing which is called like a new Loki plugin written in C language, which is more performant and allows you to send all the data to a Loki backend by using the same binary, the same agent.
Okay.
So you no longer need to have a special version with a special container and, mixing up versions, which is really complex. Today's users want to have a more unified experience, a single agent that has everything right out of the box. And a new addition that we got in this version is new Kubernetes events plugin. So this allows to connect to the API server and retrieve all the events for the cluster, or you can segment the events by namespace. So you can just go ahead and say, I want to retrieve all these messages from this namespace, and then you can do all the processing that you want. Or you want to match something, you want to write some custom script that says, if this data contains this information, for example, send me a Slack message, or do something with this, or trigger an HTTP call in an endpoint, so you can do some alerting or all type of. The biggest one is performance improvements. As you know, people who use Fluent used to do a lot of processing and filtering, and now we have improved the stack that if you are using the classic filters, not the processor, for the filters that 90% of the people are using today, we get a 6 times performance improvement.
Oh.
Yeah, as a simple example, with 3 filters, we were able, for example, to process around 15 messages per second. In one example, of course, if you put more load, you will get different results, right? But from 15K, we got to 93K. We did a lot of optimization. How do we buffer the data? How the filters change together? And this is the biggest outcome for everybody. And you just need to update the version. And yeah, another cool update from the community. Phil Wilkins, a community member, started writing the Fluentbit book. And Kautilya, the company that we have that supports Fluentbit is also supporting this book, right? And now we did a support where this book will be available for most of folks in Kubecon and who's watching this video on YouTube from the Henrik's channel. So just scan this QR code, fill out the form, and you will get a link to that with a copy of the book that is still under development. And if you don't want to just fill the form because you're sensitive around data, right, just wait until March and buy the physical book. And as I always said, in observability, you have to be fluent, right? Be fluent with protocols, be fluent with different ecosystems, and that's our depth for Fluentbit to that.
I'm Matt Ray. I'm a sales engineer over at Observe. Obviously, we're an observability company, as the name implies, and really we're designed around being able to take any machine data and bring it into our platform, right? So we have one centralized data lake. You get your data into our platform, and then we allow you to manage, correlate, and view all of that data in one centralized location.
What type of data are you able to ingest? Is it Prometheus? Is it open telemetry? So can you just a bit more about the format supported?
Yeah, so at the end of the day, we can take any data that you have and you generate. Our primary collection methods are based off of open source collectors. So things like Prometheus, OTel, Fluentbit. But we also work with customers that ship data from their CRM or from GitHub. As long as you can generate the data, we have the ability to collect and utilize it within our system. Yep, metrics, traces, logs, the big three that Grafana popularized, of course. But then on top of that, we can bring in things like customer data from a CRM. We can bring ticketing data in from the service desk or build data from Jenkins, right? So we can bring all of this stuff in to really provide more context around the metrics, traces, and logs that you have today.
So when the data comes in, you automatically contextualize the data? Or?
Yep, so we have it pre-built to automatically contextualize the data. So we will build out what we refer to as a data graph, right, where we can do things like tie the logs that are being generated to the traces that are within your environment. Past that, we give you as a user the ability to build additional correlations and manage those within our platform as well. So right now, what we're looking at is our data graph. Right, and so this is really us starting to build out the correlations within the environment. So you can see we have Kubernetes here. It's correlated with AWS as well as some OTel data and Jenkins. So right now we're zooming in to look at a pod, and that pod has been correlated to the containers, which then are correlated to the container logs, metrics, so on and so forth. So what that does is as we move into the log explorer here, we have the ability to pick and choose a time frame that we want to look at from a logs perspective. And then here we can go and extract fields on demand, utilizing what we refer to as schema on demand, in order to actually be able to pull out additional information and go directly into creating a visualization. And from here, we'll go through and modify that visualization a little bit to make it more useful to us, and then post it onto a dashboard as we go. So you can see that there's some filters being applied right now utilizing the query builder. We also have the Opal tab right next to it, which is where that query language comes into play. So definitely power users, people used to SPL, can live in that Opal for doing those sorts of queries. And then if you ever have a question about the platform, we've also integrated GPT in order to be able to ask questions and get answers utilizing Ollie GPT there.
So you're mainly linking OpenAI to your documentation, so people can have access easy to how to do things in the UI.
Yeah, so that's a developing field for us, as it is for many people. The first one for us was having the GPT model based on our logs, our documentation. We also can use it for code autocomplete when you're writing the query language that we talked about earlier, as well as doing things like regex parsing, which is super helpful when we're going out and parsing logs, because everybody knows what it's like to write regex, right?
And so do you provide any extra, for example, you mentioned OpenTelemetry. Do you provide specific processors to make sure that the data that has been built by users are pre-contextualized? So then you're already sort of have a massage. The data has been pre-massaged when it comes into Observe.
Yeah, so we have pre-massaged kind of views and visualizations and content for OpenTelemetry, as well as things like Kubernetes, all of your major cloud providers, all kind of set up and ready to go out of the box. So we can do things like very easily correlate a container to the metrics associated with the containers. We're moving between, say, pods or logs and metrics, and between Kubernetes and AWS. But then, of course, as a user, if you want to include additional business logic, we can show you how to build out and manage those things yourself. So our kind of default collection for Kubernetes is essentially a Helm chart that deploys Fluentbit and a Grafana agent that we use to collect logs and metrics, as well as a container that we use to collect some state information. But of course, if you already have things like Prometheus collecting custom metrics, we can easily use like Prometheus remote write in order to send that data over as well.
Okay, cool. So if I want to get started to observe, do you have like a freemium or feature, or do you have a how does it work?
Yeah, so it's observing.com. We have a free trial as well as a sandbox environment that has some pre-populated data where you can give it a try and get started with either our sample data, or you can send us your data as well.
Principal software engineer at Microsoft, and yeah, I'm the technical lead of the Inspector Gadget project that we were going to talk about today. Inspector Gadget is a framework that allows other people to build tools based on eBPF. So the issue is that there are many different tools that are using eBPF to get data from within the kernel, and most of the tools are doing the same things. So we realized that we could be creating a framework that could be useful for the whole community there. So Inspector Gadget allows developers to create their own BPF programs, to put those BPF programs into OCI images, and then Inspector Gadget takes care of deployment, running those BPF programs in a Kubernetes cluster or also in a Linux machine. Additionally to that, this is like a technical detail, but I think it's important. When we collect data from within the kernel by using BPF, we have like very low level data. So we need a way to correlate that data with different concepts like Kubernetes pods, containers, and so on. So Inspector Gadget has all the logic available for the developers, so they don't have to worry about all of that. In Inspector Gadget, we try to be as agnostic as possible. So we are not an observability tool, we are not a security tool, we provide data, and this is up to the other applications what to do with that data. I know eBPF is great, but at the same time it's like a little bit difficult to handle eBPF programs. There is a bunch of logic that you have to write, so the idea with Inspector Gadget is that you don't have to worry about all of that. Inspector Gadget is going to be like the common framework for deployment of eBPF programs in Kubernetes and in general in Linux. We have different gadgets available. Basically, a gadget is a eBPF program, some configuration file, and in some cases, some WASM modules. So those gadgets can be used for different things. So yeah, let me show you one of them. I already have a Kubernetes cluster running here, and what I'm going to do is to run one of the gadgets that we provide. So for instance, this is one of the gadgets that provides information of when processes are executed in the system. So I'm running the gadget. As you can see there are some different columns, some different information there. In the bottom of the screen, I'm going to run a pod, a shell into a pod. And yes, so if I run different commands, we can see how those commands are traced on the screen above. So let me run a ping. So as you can see there, we have this information that a ping command was executed. So what is interesting here is that all the information that is on the right of the screen, the Kubernetes node, the Kubernetes namespace, pod, container, all of that is provided by Inspector Gadget. And the information that we have somehow on the right part of the screen is provided by the eBPF program. And yeah, so I can show you another example of that. So another gadget. So we have TCP Connect. So this one is for tracing TCP connections within the cluster. So if I try to access one service that I'm running here, we can see that we get the event. So in this case, this is also interesting because in the as source and as destination, we are not only providing the IP address, but we enrich the data. So we actually provide the namespace, the pod, and the service where that connection is going to. So the idea is that when you are trying to debug something in Kubernetes, sometimes it's difficult to correlate the data that you are getting from eBPF, from the kernel. So Inspector Gadget helps by providing that as additional data to you.
So you're automatically adding the community data to the DBF folks that are sent.
Yeah, that's right. We add all of that metadata to the events that we get from the kernel.
If you want to install Inspector Gadget into this cluster, what would be my journey?
Yeah, right. So there are different options. We can use Helm, but the easiest option is to go to the Inspector Gadget repository. If we go to the different releases, then we have different binaries. So we have to grab the kubectl gadget binary. So that's a plugin for kubectl, and then we can run this command. Actually, before this demonstration, I already have that deployed on my cluster. But yeah, that's what we have to do. So we will have to run kubectl gadget deploy to install that in the cluster.
Litmus Chaos, which is a CNCF open source chaos engineering software tool. I've been out of Minneapolis, Minnesota. I've been a DevOps engineer for the past 10 years, worked at Target Corporation for quite a while, and now I'm here today just teaching people about chaos engineering. So
a lot of new things that's happening on Litmus. So could you talk about the new stuff about Litmus?
Yeah. So Litmus Chaos is an incubating project with the CNCF, and we have about 30 public adopters. And over the past year, we've gotten a lot of great feedback since a year ago at Detroit KubeCon. So some of the new features that we basically are implementing is helping companies scale with a great user experience. So we have a new UI that's very clickable, less buttons to actually run a chaos experiment, and more portable, meaning you can take chaos experiments to them and put them in your chaos hub so that you can share them with your own users across the company. We also have these new things called resilience probes. So before they were baked into your experiment, but now we lifted them out to be a first-class citizen. So you can actually create, let's just say, 5 resilience probes that measure certain metrics across your company, and then you can associate all of your experiments to it, so you can share them out and understand the reliability of not just one service, but all of your services and how they impact.
I remember that there was a plan to do application fault injections. So where is that project at the moment?
Yeah, so for that, right now, application fault injection is definitely a more mature use case, but with a lot of folks, we're doing HTTP chaos and everything, so users can run, networking experiments on their APIs and, inject inject faults into their headers and kind of just make sure that, the certain error codes that come back to the users respond in a meaningful way. Over here, we'll just walk through the things. So first of all, we have a new overview page with improved UI, UX experience where we're lifting more of the information of the chaos experiment to the users so they don't have to click through as many screens to understand the reliability. One thing that we added in was environments. Sounds basic, but what's great for our users is they can identify prod environments, QA, a demo environment even, just so they can kind of share across their organization and have more security as well as they're kind of putting chaos engineering throughout their whole organization. Another thing we did is added some more information. So when you actually click into your environment, you can see that it's connected. You can understand if there's any issues, and we actually help you troubleshoot if there are issues with getting connected, which is important because a lot of new users don't need to be Kubernetes experts to run chaos engineering. So we actually help them run some commands so that they can install it and run it. And even when you're upgrading from one agent to another, we help the user kind of with that. And then with chaos hubs, right now we have 50 experiments out of the box that people can use. A lot of these have been donated and contributed by our user base, but most of it right now focuses on resource exhaustion, right? So people that want to test auto scaling procedures, they can run CPU or map array, which is basic, as well as just platform engineers that want to do platform reliability, making sure they meet their SLAs for the application teams putting on. This is the resilience probe section. So now, rather than having these probes buried in the experiment, they're lifted into a first-class citizen. So you can actually see here we have 2 probes basically for service checks. When you click into it, though, you can actually see which experiments are utilizing them and how they're running. So you can actually click into it, and then you can configure these probes so that they actually apply to all the experiments. Because before, you got the feedback that you had to go into each experiment, click into the probe, and change it, which wasn't very scalable, right? So now based upon feedback, we've got your contributions in so that you can manage the probes as a first-class citizen, which is huge. And then if we look into our workflow execution of our pipelines here, you can actually see the history of the resilience probes as you run the experiments, which is great for identifying configuration drift between the system. So this is an experiment where one of the probes failed. So as we introduced CPU into the system to extend the resources, we actually had the boutique, the web latency basically was delayed, so then we failed the experiment. So we have that automation of a criteria to know if your experiment passed or failed. And then in a successful case here, both of these probes passed, so you get a 100% resiliency score. And again, what that means for the user is when they come back here, they can see day-to-day or run-to-run, how their resiliency score has increased or decreased, which provides a signal to the system hey, something changed, I gotta go look into it, right? So those are some of the great things that you can see in the UI. Also, we extended more, our API has improved APIs, so you can do better reporting, and then if you don't want to click on any buttons in the UI, you can run everything from the API. We also use MongoDB for our database for all the experiments. We made that high availability now. So users, again, from an enterprise perspective, have that database that's reliable and performant. We also have some scalability with the experiments, so you can manage through your targets a little easier. Before, you had to click into your target and run an experiment, but as you think about scaling out to an organization, how do you want to manage reliability on your Kubernetes clusters, nodes, pods, and containers? So now we can scale our experiments more granular as well as more focused across the enterprise as well.
Did you do any optimization to reduce the footprint of Litmus in the cluster as well?
Yeah, for sure. As we've gotten more adopters, they've given us feedback that we can make, our images and footprint just less, right? They don't want, when you install an open source project, sometimes you don't know what the size of that environment is, but here we kind of refined it just so it's more of like, commercial product in a way, right? Where it's efficient, it runs clean, and security teams can look at it and know that it's safe and secure, and they don't have to do as much of like an audit on it anymore. And that's, we're trying to get to that graduation state with the CNCF, so we're building up and ramping up for the checklist, that we have to do for that too, so.
All right,
yeah.
Cool. And I know that Litmus was organizing a conference, so when is it? Can you talk, is the CFP still open? So.
Yeah, so we go to Chaos Carnival here. So January 24th and 25th of 2024, we have our 2-day virtual event for Chaos Carnival. We're getting CFPs right now. It's our 4th annual event, so this is the 4th year. We have speakers from United Airlines, the government. Uma Makaro is going to be keynoting again, who's the head of chaos engineering for Harness, as well as the person that donated Litmus Chaos to the CNCF. And again, if you have a CFP that you want to submit about observability, SLOs, chaos engineering, or just like the general psychological safety of working in an environment, you can submit that and we'll review, and we'll see you there.
That's it for today's episode related to Kubecon North America. And I promise it's the last episode related to Kubecon North America 2023. So, first of all, I think pretty exciting news about Litmus Chaos. Lots of great improvement has been made, I think, on the UI perspective, on the performance side. And I really like the fact that the probes now are separate from the experience. I think that would allow us to have more probes running, checking different things for different experience. So a better way of realizing the probes between experience. On the Fluentbit side, again, really great to see that lots of improvement has been made, adding more metrics receivers, more capabilities to process and filter metrics and so on. So I think it's really exciting to see where it's going, and I'm very eager to learn about Fluentbit 3.0 that will be announced in KubeCon Paris. I think now with all these updates, we may ask ourselves, should I use the Fluentbit agent or should I use the collector? That's a pretty good question. And I think to answer that question, I may try to do some benchmarking, comparing the behavior of each agent depending on the load and the volumes of data that we're transmitting back to our backend. And I think that will be a good start, helping us to decide which agent we should use in which environment. All right, so if you enjoyed today's content, don't forget to like and subscribe to the channel. And see you soon for a real traditional episode on technology. So see you.